Thank you everyone for coming out this evening. My name is Dehmler. I'm a PMP. I've been a PMP for 4 years now. I just recently finished a project at the Office of Information Technology Services here at the state for the Chief Portfolio Office in the governance section. I have worked on projects in Spain in e-commerce, had the privilege of running some multicultural projects in Spanish and English. And in my formative years of my career, I started out at Bausch & Lomb, which was a medical device manufacturing organization where I got some experience in quality management and in project management. And about 4 years ago, I decided that it was about time for me to take into this project management experience and take it to the next level and get my certification. That's how I ended up taking my PMP exam, learning about it through another project manager in Spain who took his test in Spanish. This gave me the opportunity and the thought process to go ahead and take this certification. And I know many of you here this evening are looking forward to taking that test. I'm hoping that this class will help you understand some of the concepts within earned value management, which is what we're going to be talking about this evening. The PMBOK has defined earned value management as a methodology that combines the scope, schedule, and resource measurements to assess project performance and progress. In essence, it's really just a group of formulas that allows a project manager to have insight on the financial and time progress of a project. It also will assist a project manager to forecast future performance based on performance that we've had in a previous time so far within the progress of these projects that we're working on. It's really a great concept once we learn a little bit about it to help us manage and control costs within the project and the schedule. This evening we're going to use an example that will go through the process of a project example that we'll use for understanding the different concepts of earned value management. We'll go through that. I'll explain the process a little bit, each one of the concepts. Then we'll go through one whole process, one example that we'll have based on our May the 4th be with us next week, our awesome holiday we'll be talking about. And then we're going to go open up the session to questions based on the topics that we've discussed. The project that we're going to use as an example is that you're a project manager for a state park. Here we are in Albany. We help the rest of the state, and one of those things that we really love about our state is that we have some of the best state parks in the whole United States. Livingston County Letchworth State Park was named #1, and we had Watkins Glen, which was named #3 in the United States in 2015. We should be proud of that. We come from a great area of the nation. Now, this project that we're working on, we're going to construct 20 miles of hiking trails inside of this state park. And the plan indicates that each mile of hiking is going to cost $1,500 to build. It's going to take us 8 weeks to complete this project. And what happens is in 2 weeks into the project, we've realized that we've spent $5,500 and that we completed 4 miles of the hiking trail. What we're going to do is we're going to take a look at some of the concepts of earned value management, and we're going to report the performance and determine any remaining times and costs associated with this particular project. Do some nature. Summer's coming along. The first concept that we're going to talk about is budget at completion. Budget at completion really is one of the simpler topics within earned value management. It really is us going through our determined budget that we've done within our estimating. We've done our analogous estimating, we've done our parametric estimating, and as a result, we have a budget that considers the whole project as a whole. It is how much we originally expect the project to cost. In our project, it is $1,500 per mile, 20 miles. Our budget at completion is going to be $30,000. Then we're going to talk about planned value. Planned value is how much work was planned at this point in time. It's always expressed in dollars, and I want to kind of talk a little bit about planned value because it's important to understand that planned value has a time factor involved in it. This will help us recognize and understand why planned value is used in certain areas, for example, schedule, as opposed to our cost index. The formula for our planned value is the planned percent complete times the budget at completion. We've already just figured out what our budget at completion is, so now we want to know what our planned value is. In our example, we talked about completing 2 weeks of the 8 weeks of the project. So we have to figure out what our planned percentage completing is. If we take a look at that, 2 weeks of 8 is 25%. 2 over 8, 1 over 4, 1/4 is a quarter, 25%. So 2 weeks equates to 25% of the project. Therefore, our planned value is going to be 0.25 times 30,000. Therefore, we have a planned value of 7,500. Again, remember, planned value takes into effect a time factor. That means our 2 weeks is what we have planned. Now we're going to talk about our earned value. Earned value is simply the assumption that as you complete work on a project, you have earned the value of the tasks that you have completed. I look at it as simply adding together the value of the tasks that you've completed. You sum them, that becomes your earned value. You have earned something because you have worked and completed those tasks, and those tasks had a value. Our formula for our earned value is the actual percent complete times the budget at completion. Now for our example, we have to think about how much did we actually complete. We just talked about our planning and what we planned to complete. Originally, in 2 weeks, we planned to complete 5 miles. But in our actual 2 weeks, we've only completed 4 miles. Remember, that's what we talked about at the beginning of our project, that we completed 4 miles at the end of 2 weeks. Therefore, we need to calculate the percentage. 4 miles is equal to 4 miles of 20, 1/5, which is 20%. So we take our formula, which is actual percent complete, which would be 20%, multiply it by our budget at completion, and we get our earned value. Our earned value is 6,000. Let's think about this for a moment. That kind of sounds logical, the formula of calculating the percentage and everything like that, but logically we can sit there and think about it. We completed 4 miles. Each mile is worth $1,500, correct? So that is 1,500 times 4 equals 6,000. So we've looked at it in both manners. We looked at it based on the formula that we've had, and we've logically understood from what our basis is that we've got the 6,000. As we get into more complicated projects, of course, we want to use the formulas so that we don't have to sit there and think about it logically. We already know and understand the formulas that helps us calculate these particular topics. Our actual costs. Believe it or not, there's places that can't actually figure out their actual costs, but actual cost is a given. It should be something simple for us. It is adding up the receipts of the expenditures that we have done. Generally, when we are at a point in time of our project, we should be able to know exactly how much money we have spent in order to achieve what we have achieved within the time period that has passed. In this case, we have calculated that we have actual costs of 5,500. It is a given. We already know this based on calculating the receipts of money that we have spent. So budget at completion and actual costs are relatively simple to calculate. Planned value and earned value are relatively simple to calculate too. It's just kind of understanding the concepts behind them. Now, these 4 concepts are the ones that we will use to calculate the majority of our earned value management calculations. And we generally, at any time in the project, will be able to know what those facts are, okay? Because budget at completion is something that we've always known from the beginning of the project. Before we've entered the execution phase, we have planned and we have created our budget. We have determined our budget. We'll know that. BAC will be a known fact before we begin execution. Actual costs will be easy to calculate because we will always be able to know the actual cost because we have the bean counters that will tell us how much money we have expended, okay? Our earned value will be calculated based on the tasks that we completed and the time within which the project we have finished. Now we're starting to get to the fun part. We're starting to calculate some numbers. Cost variance is simply a difference between what we have earned and what our actual costs are. The way I look at it is it's the actual costs differ from what our earned costs are. It is the summation of the tasks that we've completed, our earned value, subtracting out the actual costs. In our example, we determined that our earned value was $6,000, right? We've completed 4 miles of the hiking trails. Those 4 miles represent $6,000 of earned value. Our actual cost, because our bean counters told us after these 2 weeks, we have done $5,500 worth of expenditures. Therefore, we're going to take our $6,000, we're going to subtract out the $5,500, we'll get $500. The variance is positive. A positive variance is good. It means that we are under budget, okay? We have spent less money than what we have actually earned. So therefore, it's positive. It's good for us. We want to earn something, right? Negative cost variance means that we have earned less than what we have spent. We don't want to see that, do we? We don't want to spend more money than what we've earned. And if we do spend more money than what we earn, we have a negative number. The cost variance will be negative. Our schedule variance. This is the same concept. It's how much our schedule differs from our plan. We express it in dollars. Schedule is time. Time can be complicated to pass the numbers back and forth. Think about Excel. Think about all those weird numbers that Excel calculates when you put in dates. It might show the date, but there's this weird number behind it. This is why, as project managers, we calculate our schedule with dollars. We kind of convert that over using our planned value. Remember, planned value has a time factor in it, correct? What we do is we're just taking the difference between our earned value and our planned value, and then that will help us identify our schedule variance. Now take a look. Our formula here is schedule variance is equal to our earned value minus our planned value. Therefore, our $6,000 schedule our $6,000 earned value, we will subtract out our $7,500 planned value. Remember when we calculated that earlier, $7,500? It's because that in the 2 weeks of the 8 weeks, we completed 75% of the project. So therefore, we calculate 75% of what our full expenditure would be, the $30,000, and we're going to get our $7,500 that will subtract out and therefore have a schedule variance of $1,500. This is positive. Negative. This is bad. Remember what we talked about. If we have a negative number in a variance, we are going to get a notice that we are behind schedule. That's what our schedule variance tells us, positive or negative. Now we're going to take a little bit more concept here, and we're going to talk about ratios. We're going to talk about our indexes. We're going to talk about, to start out, our cost performance index. Our cost performance index indicates how much we are getting for every dollar spent. It really is only a ratio. X amount of dollars earned for every dollar spent. To get a ratio, we're going to take our earned value and we're going to divide it by our actual costs. Remember what our earned value is. Our earned value was $6,000. We completed 4 miles. We've earned the value of those 4 miles, which was $6,000. Our actual cost was $5,500. Therefore, our cost performance index is 1.09. This is awesome. We want 1.09. We want a number higher than 1. Because a number higher than 1 for a cost performance index tells us that cost-wise, we're performing better. We are under budget. If we have a number that is less than 1, it's telling us that we're over budget because we're progressing at a rate lower than every dollar we spend. So in other words, in this case, in our example, we're getting $1.09 of earned value for every dollar that we spend in the project. And that's awesome. That's great because we're getting more out of that than what we actually spend. Now we're going to talk about the Schedule Performance Index. This is the same concept. It's how fast the project is progressing compared to the project plan. Remember, we have talked about the schedule including a time factor in it. This is why we use planned value for determining our schedule variance and our schedule performance index, because planned value is the amount of tasks that we plan to complete in a given time period, which is important to understand because this is why we can use planned value towards our schedule performance index and our schedule variance. Basically, again, this is just a ratio of how much time dollars we've earned for each planned time dollars that we have in our project plan. The formula for this is earned value divided by planned value. Again, we use planned value because it has a time factor involved in it. It's always being used when it comes to your schedule, planned value. Therefore, our plugging in the numbers to the formula, we will see that we have 6,000 of earned value and our planned value of 7,500. When we do the math and divide them out, we're at 0.8. Our schedule performance index is 0.8. Remember, it's the same as our cost performance index in the sense that we want to have higher than 1. Higher than 1 is good, lower than 1 is bad. 1 indicates we're running right at schedule. Less than 1 at 0.8 basically means that we're progressing at 80% of the pace we had originally planned. So if we take a look at our original plan, we can understand that. We can logically look at this because we completed 4 miles of what we planned for those first 2 weeks, right? We planned to finish 5 miles in the first 2 weeks, and we actually completed 4 miles. Therefore, it's 4/5 of what we planned. 4/5 is 80%. Estimate at completion. Estimate at completion has different formulas that we can use to calculate this number. It is based on different assumptions. Now for you as PMP students, you're going to use this one as the main assumption if the other assumptions are indicated. Based on the scope of this class, we're only going to talk about this one particular formula. But keep in mind, there are different formulas to estimate, to create our estimate at completion. Really, the way I look at estimate at completion is it's a revised budget at completion based on the performance so far in this project. Now let's take a look at the formula. The formula here for our estimate at completion is budget at completion divided by our cost performance index. What this is telling us here is that we're expecting that the progress of the costs associated with this project will be the same for the rest of the project as what we have seen for the beginning of the project. So the first 2 weeks, our cost performance index was 1.09. So the rest of the 8 weeks, we're expecting that every time we expend $1 to build our hiking trails so that we can go see the beautiful nature that we have in this state, we are going to expect that for every dollar we spend, we will earn a value of 1.9. So therefore, in order to get this, we take our budget at completion of $30,000 and we divide it by our 1.09, and we're going to get $27,522. Sounds logical, doesn't it? Because didn't we see at the beginning with our cost variance that we had a $500 variance, didn't we? To the positive, to the good. It meant that we expended less than what we had expected to expend in the first 2 weeks. So therefore, extending that out and taking a look at that in the future, if we're continuing at the same rate, our budget is going to be lower. Our estimate at completion is going to be lower than what our original budget at completion is going to be. Now let's talk about our estimate to complete. And sometimes those two can be a little bit confusing. Estimate at completion and estimate to complete. But let's think about those prepositions, because at means at the particular point in time. It's at the end it's at the completion. Whereas estimate to complete is the estimate to continue through the project and finish. It's simply taking our new estimate at completion and subtracting out the actual cost. It is us looking at what we have to expend from this point forward based on what we've done in the past. So our formula for this is estimate at completion, for the estimate to complete, is our estimate at completion minus our actual costs. This number can change because EAC, remember, there are different formulas for EAC. Therefore, these numbers can change depending on what assumptions you're making. Our assumption for this project is that we will continue at the same cost performance ratio that we did in the first 2 weeks. That's what we did. That's how we calculated our estimate at completion. So therefore, we're going to take our estimate of completion, which was based on our continuing at the same rate, and we subtract out our actual costs. So therefore, our estimate to complete is $22,022. Another concept, variance at completion. Here we're going to go back to the topic. For any variance, positive is good, negative is bad. It's logical. For example, with our variance at completion, it's the difference between what we had originally budgeted for the whole project and now what we expect to spend for the project. So it's our BAC minus our EAC. It's our budget at completion, the original one that we determined, minus the estimate at completion, the one that we just determined based on the performance that we've done so far. We've done our human resources properly. We got someone in there that works a little bit better than what we had actually estimated someone would work, or any number of reasons why we might be running a little bit smoother. Maybe our Tuckman's ladder has helped us get quicker to the performing stage and reduced our storming. So therefore, our variance at completion in this case is going to be our $30,000 that we have budgeted at the beginning of the project minus what our new determination for the estimate at completion is, and we come out with a variance of $2,477. Positive. Positive means good. Positive means we're going to be under budget. Sounds logical. If we were under budget in the first 2 weeks, our actual costs were less than our earned value, then it sounds logical if we're running our percentage, our performance index, to be equal to what it was the first 2 weeks. The next 6 weeks, our budget will just increase as far as being under budget. Now we're really getting to the fun stuff. two complete performance index. There's a little bit more numbers involved with this. It makes it a little bit more fun to calculate what this is. And really, all the two complete performance index is a number that we need to calculate that will tell us what performance we have to achieve in order for the remaining work to come in within financial and scheduled goals. In other words, it's taking the numbers that we have, throwing them around a little bit, and trying to figure out what number, what index or what ratio we can have in order to achieve the goals that we've already set out originally. Now, what I want to say about this is that you can use this to complete performance index both for your costs and your schedule. But for the scope of this class and the scope of your PMP exam, you're not going to use the schedule part of this. We're only going to take a look at the cost performance index of the two complete performance index, only the cost portion. Now let's take a look at our formula here. Our two complete performance index. It is basically the budget at completion minus our earned value divided by our remaining funds. Now, how easy is it for us to determine our remaining funds? When we first started our project, we know that we got plunked down a bunch of money. In this case, for our hiking trails that we're building in our state park, we got $30,000. That's what they gave us. They said, okay, that's what you budgeted. You've determined it. You've done your analogous estimating. Here you go, $30,000. What have we spent? We have spent $5,500. So that's the actual money we've spent. So in our pool of money, we have $30,000 minus the $5,500. That means we have $24,500 remaining. Simple, easy process to determine. Then we have to take our budget at completion and subtract out our earned value. The way I like to look at this, that top part, this BAC minus EV, is we're trying to calculate our estimated earned value, and that's what it is. Our budget at completion minus our earned value gives us $24,000. That's our estimated earned value that remains in the project. So that's our earned value divided by our actual costs, right? The bottom part, that $24,500, is our actual cost. I put that in quotes because it's not really our actual cost. We don't know that, but we're going under the assumption that that's what our actual costs are going to be. We're going to use up the remainder of our budget. Therefore, we have $24,000. We divide it by $24,500. We get a number 0.98. That means that we have to run at 0.98. We have to get 98 cents for every dollar we spend in order to meet our original budget. This is the time when an index number is better to have below 1 than it is to have above 1. Why is that? Because below 1 means that we don't have to generate as much earned value on the dollars that we spend. So therefore, to meet our budget at the end, we don't have to generate as much earned value. So that's to our benefit. It doesn't mean that, it means that we have to overperform to get our budget if we have something over 1. Because if this number comes out to be 1.09, we have to make sure that we get $1.09 for every dollar we spend in order to meet budget. So for us as project managers who've just worked hard for the first 2 weeks of the project, we want it to be a little bit below 1, because then we can kind of slack off a little bit, right? In order to complete our project? No, of course not, because we're creating hiking trails so that everybody can go out and enjoy nature in the state parks of New York State. I want to take a look at a traditional reporting chart. We just take a look at this for a few minutes. We've covered the majority of our concepts. We're going to go use an example, and we're going to go through an example of those. But before we do that, I want to talk about this traditional reporting chart. Because if we went in and a CEO is taking a look and he says, look, this is what our budget is, our planned value, right? And then he says, look at our actual costs. And what does everybody say? Woohoo, woohoo. All right, we're below our budget. We're saving money. That's awesome. But we're project managers. We've studied earned value management. We know that this is a trick. Why? Because actual costs don't relate to planned value. Why? Because planned value has a time factor involved in it. Planned value says that at the end of 2 weeks, we are going to accomplish this amount of tasks. But actual costs don't represent that. Actual costs only are what we have spent. It doesn't go towards any particular task. It's just what we spent our money on. So we can't take those two and actually meld them together because there's something there that's missing, and that is the time factor. This is why we've created the concept of earned value, because then we recognize what we have earned, what tasks we have accomplished, and the value of those tasks. Let's take a look at a couple more charts here, and it'll kind of help us understand that a little bit. Because understanding the concept of earned value, that we have completed tasks, and because those tasks have a certain cost associated with them, that's the cost that we say we have earned. If we look at this here and we see earned value, we see that earned value is lower than actual cost. Immediately looking at this chart, we understand that our earned value, that we are what? Behind budget. Because if we take our earned value, which is a lower number than our actual cost, and we subtract it, we are going to have a cost variance that's negative. That's why we have to understand these concepts, because earned value is what is going to help us recognize better this time factor that's involved in planned value. Let's look again. Now let's take a look at earned value and compare it to planned value. In this case, with this particular graph, what can we tell immediately? We can tell by seeing that our earned value is less than our planned value that we are behind schedule. Why? Because when we take earned value, which is a lower number than the planned value, and subtract out the planned value from the earned value, we will result in a negative number. It shows us that our schedule variance is negative, and that means we are behind schedule. And that's why we have to have this additional graph, this additional line in here, in order to understand whether we're behind schedule, ahead of schedule, behind, over budget, or under budget. Because having earned value is the addition of taking out that time factor from planned value and making that earned value recognize the difference between planned value and actual cost, because it's not recognized in that first graph. And again, if you take a look at it, our earned value is lower than our actual cost, so we know immediately we're behind, we are over budget, because earned value minus actual cost is going to be negative. And the same thing for earned value minus planned value. Since it's a smaller number, earned value, you subtract out the higher number, planned value, it's going to be negative. We're going to have a case where we're behind schedule. Now the fun part. Since we have this tremendous holiday that's coming up, May the 4th be with you, and we had talked about possibly doing this class on that day, I decided that we would talk about building our Death Star. As we can see, our Death Star is not completed yet. We have a project that is unfinished. We are going to talk about this scenario, and we are going to see exactly where we are in the construction of our Death Star. We are building a Death Star to help the Galactic Empire conquer more planets. We are going to bring to those other planets the freedom and structure that the Empire will bring to them. What we are doing is we're planning to build the 4 sections of the sphere in 4 years, spending 1,000 galactic credits each year. At the end of the 3rd year, we had 1.5 sections completed and had spent 2,250 galactic credits. Now we got to talk about this because as project managers of this advanced civilization, we need to do what we can do in order to bring this Death Star up and online in order to go out and conquer some more planets, right? Don't we want to bring the freedom of the Empire to the rest of the galaxy? So tell me, project managers, what is our budget at completion? I have given you the scenario. I have given you the definition of budget at completion. Based on this information, what is our budget at completion? $4,000, correct. Budget at completion is what we budget it to cost. 1,000 galactic credits each year for 4 years is 4,000 galactic credits, right? Didn't know you were going to learn about galactic credits tonight, did you? So what's our planned value then?
What point of time? At the end of that year?
At the end of third year, what's our planned value? How much? 3,000. Our planned value is 3,000. It's what we plan to have done at the third year. Now let's let's think about that for a second. How do we calculate that? It's our planned percentage times our budget at completion. So our planned percent complete at 3 years is 3 out of 4, correct? 75%. That's our planned completion so far. 75%. 75% times 4,000 is how much? $4,000 times 75%. 3/4 of 4,000 is 3,000. So, logically we can see this because it's 1,000 per year and we've completed 3 years. So it's 3,000. But the formula is planned percentage times budget at completion. Do the numbers. I know your algebra teacher complained to you all the time in 9th grade, follow the procedure, don't figure it out in your head. I want to see lines. If you got lines, I give you credit. That's what that's about. Because right now it's easy for us to see that the planned value is 3,000. But when the numbers get weird, because right now it's kind of simple, but really it's to the 6th power, because you think 1,000 galactic credits is going to build a quarter of a Death Star? No, it's to the 6th power. And those numbers get a little crazy. So we want to use the formulas. Now what about our earned value? What is our earned value? How much? 1,500. Do you agree? Our earned value is the summation of the tasks we finished at the end of the third year. What's our formula for our earned value? Actual percent completed times budget at completion. So our 1.5 of 4 is 37.5%. Therefore, multiplying our budget at completion of 4,000 times 37.5%, we will get 1,500. How about our actual cost? What's our actual cost? 2,250 what? Galactic credits, right? Remember, the science teacher used to say that all the time, right? Tell me what it is. Correct. This is a given. Now let's hope that based on our advanced civilization where we're building our Death Star, that our bean counters know exactly what we need and can give us that actual cost because they've counted properly and they've made the receipts about what they've paid everybody. How about our cost variance? What's our cost variance? 750 what? minus negative galactic credits, right? 750 negative. How do we arrive at that figure? How do we get 750 negative? Earned value minus actual cost. That's a definition of our cost variance. What does this tell me, this negative 750? What's that? Negative's no good. Correct. And it's no good because we spent more than the tasks were worth. That's why it's negative. We overspent. How about our schedule variance? What's that? Minus 1,500? It means we didn't finish the work in a planned time. What's the formula for that? How did she arrive at that number, schedule variance? EV minus PV, which is what spelled out? Earned value minus planned value. Remember, if it has to deal with the schedule, it's always planned value because it has the time factor in it. Keep that in mind. How about our cost performance index? What's that? Earned value over actual cost? Good. So what's our number here? Come on, we got phones that can send us to the moon here. These computers are more than the computers that they sent people to the moon with. How much is it?
66%.
66? 666. It's the evil rebels. That's what it is. That's why we're so far behind, because those rebels are in there stopping us from building our Death Star to help bring enlightenment to the rest of the galaxy. What this is telling us is that we're getting 0.67, or we're getting 67 cents of a galactic credit for every galactic credit that we spend. That's the point of our cost performance index. That's what it tells us. It helps us understand that we're not earning value on what we're spending. And remember, lower than 1 for cost performance index is bad. How about our schedule performance index? 0.5. That's a great number, isn't it? Isn't that great for schedule performance index? What's this telling us? We're behind schedule. Quite a bit behind schedule, aren't we? It's those pesky rebels. They're stopping us from building this Death Star. That's why we're so far behind. We need to get out more guns. Oh, sorry. You guys are supposed to tell me that number. I'm not supposed to tell you. What's our estimate at completion? 5,970. How did we get to that number? What's our formula for our estimate to complete? Excuse me. Estimate at completion. Budget at completion divided by CPI. Now remember, estimate at completion, there are different formulas to calculate this number. You have to make sure you are reading the questions properly to understand what assumption you're supposed to make. This assumption that we use here for our estimate at completion is that we're going to continue with the same cost performance index for the rest of the project. And therefore, we're going to have, at the same rate, a cost overrun. Now we want to determine about our cost overrun. How much is it going to be? Well, we can tell that simply because we're looking at our budget at completion and our estimate at completion, and we see that it's greater. So then we have to figure out our variance at completion. And that's going to tell us our cost overrun. What is our variance at completion? 1,970 what? Galactic credits. We can't forget that, can we? Because we have to apply a conversion rate to understand how many dollars we're talking about. That's not in the scope of this class, okay? Right now we're just going to talk about the galactic credits. Correct. Our expected cost overrun is 1,970 galactic credits. What is our formula for this? How did we get this? What's our formula for our variance at completion? Budget at completion what? Minus estimate at completion. And remember, estimate at completion is really just a revised budget at completion based on the performance of our project so far. So it's just kind of taking a different look at it to see where we're going to be at the end of the project. Now we're getting to the fun part. What is our to complete performance index? Break out those space-age phones because we're going to the Death Star. We need to get up there and finish this project because that's what those phones will do. We have so much computing power in those phones that we can send more men to the moon. What is our to complete performance index? And what is Darth Vader going to say? You must complete this performance index or I will kill you, project manager, right? Isn't that what he does? Right? So what is it? What do we get?
0.85?
No? 1.4 something? Anybody else got an exact number? What's that?
567.
No. Good try. Almost the same as our cost performance index, but it's not. Okay, we'll go with that 1.4 something. That's pretty close. We're there. 1.428. Must get 1.43 credits for every credit spent to come in original budget. Remember, this is where we talk about the execution phase. Darth Vader will want you to achieve that performance index because he wants you to come in under budget, or he will, just like he did to his generals, execute. That's the part of project management we all like, right? Now let's take a look at the chart for this. Now remember, the other charts that we looked at were in a different project. This is why you want a project management methodology, because that way you're going to keep consistent between your different projects. Because in the other project, earned value was red, but in this one, actual cost is red. Based on this chart here, and we take a look at our earned value. Which one is our earned value? Yellow-orange. So it's the smallest number. It's the lowest chart. So our earned value is lower than our actual costs, which means what? What's that? Not good. So we have a cost variance that is negative. Correct. Now let's take a look at our planned value. Our planned value is green, and our earned value is lower than that. That tells us what? Behind schedule. Because if we took our earned value, which is a smaller number, and subtracted out our planned value, it's going to result in a number that is negative. And a negative variance means we are behind or over. Okay? In this case, behind schedule. Now we've got some time for some questions. Thank you for patiently listening to the earned value management discussion and concepts. Now we're opened up for questions on the concepts that we've talked about. No questions? Everybody has it understood? Formulas are memorized? Yes? What is our schedule variance formula?
EV
EV over PV. Let's go through the back here first. All right, next one. What's our cost variance? Cost variance?
Actual cost minus
EV minus AC, earned value minus actual cost for your cost variance. Here's a trick, and we're going to see it here in a little bit. Always remember that EV comes first on all these formulas. Earned value is first, then comes for cost, it's always going to be actual cost, and for schedule, it's always going to be planned value. So for that, tell me, what is the formula for schedule variance? Earned value always comes first. EV minus, planned value is always for schedule, so it's EV minus PV. Okay. How about our cost performance index? What's our cost performance index? EV divided by AC. How about our schedule performance index? Okay, EV divided by PV. Awesome. Okay, if we need to know what our remaining funds are in our project, how do we determine that? What is it? BAC minus AC, correct. We take what our pool of money is for the project, which was our budget at the beginning, $30,000 for our first example, and we subtract out our costs from that, which was $5,500. And that's how we get what our remaining funds are, because that's going to be our denominator in our TCPI. Questions? No questions? Yes. Yes.
So this one, what we are using, this is based on the trend analysis, right?
Yes, it's based on your cost performance index.
Would you tell us about the other two formulas also, because it's quite confusing.
Yes, we can do that. Okay. Let's go on to some more questions, and we'll take a look at some of those. Okay. Other questions? No? Okay. What we're going to do is we're going to go through some questions from the chapter, from the read a book. Then I'm going to go through some questions. Did they tell you you're going to have a quiz? They didn't tell you you're going to have a quiz? They told you that you have to pass this quiz in order to get your 35 credit hours for going to the PNP class, right? Okay, let's go ahead and go through some of these questions. Do you need anything from me now? Do you need a break for a little bit for the cameras? We're good? Okay. All right, one common way to compute estimate at completion is to take the budget at completion, the BAC, and divide by CPI. That's what we were just talking about. You just asked that one question, right? This question is asking for the formula for EAC, which is BAC divided by CPI. Reviewing these formulas and reviewing these concepts and going through different practices is what will help solidify it in your mind. It's what's helped me solidify it in my mind, is just by running through the different concepts. It's good to memorize the formulas, and I know that sometimes you really want to understand behind the formulas, but the first part is to memorize the formulas and then continue to use the formulas, because as you start using the formulas with different samples, you will start to see more behind the process and why it works the way it works. Estimate at completion is a periodic evaluation of C, the anticipated total cost at project completion. Remember, we talked about that a little bit earlier, right? EAC and ETC, because they're kind of similar. Well, estimate at completion is a revised budget at completion based on the progress we have inside of our project. Remember that. It's just the same as budget at completion, but a revised number based on how far and how well or how bad we've been doing. And then our ETC is our estimate to complete, which is how much money do we need in order to finish the project? Not necessarily the whole project, but based on this point in time where we're at now inside the project, how much more do we need in order to finish the project? If earned value is 350, actual cost is 400, planned value is 325, what is the cost variance? The answer's not here, is it? The answer's 25, isn't it? Isn't the answer 25?
That's minus 50, right?
Huh?
It's
Minus
minus 50.
50? Are you sure? Why? EV minus AC? It's not EV minus PV? It's not EV minus, it's not 350 minus 325? What's that? Oh, that's the schedule. Oh, okay. That was my schedule variance. Oh, you guys were right. It's EV minus AC, therefore it's 50. A cost performance index of 0.89 means? It's awesome, that's what we want, right? 0.89? What's it telling us? Over budget.
Putting 89 cents to the dollar.
89 cents to the dollar expended, correct. So which one is that? B? D. Okay. The CPI is less than 1, so the situation is bad. Right? Choice D is the best answer. Remember, cost performance index, we want above 1. We always want to have above 1 for our indexes. A schedule performance index of 0.76 means behind schedule, yep. Sounds like the consensus is C. Is that because you guys have a read a book and you've memorized all this stuff already? You know the answers? That's why the test is based on a different book. Huh? Earned value questions ask for a calculation or an interpretation of the results. Remember, this is what I tried to state. Let's let it solidify now. Notice that EV comes first in every formula. Don't forget it. It makes it easier. It's what's helped solidify me to stand up here in front and think about those calculations and always remember, EV comes first. Makes it simple. If it is a variance, the formula is EV minus something. Variance, EV minus something. Negative, bad. Positive, good. Right? If we have a cost variance and it's negative, it means we've spent more money than what we've earned. Happens. It's not good when it does. If it is an index, it is EV divided by something. Like we said, greater than 1 is good, less than 1 is bad. When is it? What index is the opposite of that? TCPI, and why is that? If it's greater than 1, the project has to progress more, a little bit speedier, a little bit more costs, less costs, for example. That's why TCPI going the other way is nice. If it's less than 1, it's good because we don't have to run as fast. We can slow down because you don't want to trip on those stumps that are sticking out from the hiking trails that we made, right? If the formula relates to cost, use AC. There's our little trick. EV divided by AC is what? CPI. EV minus AC is what? CV, cost variance. If the formula relates to schedule, use PV. EV divided by PV is what? What is it? Schedule variance. Did I say what?
SPI.
Oh, thank you. Yes, it's an index. Sorry. Which of the following represents the estimated value of the work actually accomplished? What is it? Planned value? Oh, earned value. Okay. Geez, I thought you were saying the right thing there for a minute. Planned value, because that's what I guessed at first. And, oh, man. Yep, that's right. It was a little tricky because it's work actually accomplished. So, therefore, it is earned value because it represents the estimated value. In other words, it's summing up the value of the tasks that were completed. See, I was on that whole rhythm of tasks completed, and so I didn't say work actually accomplished, but it's the same concept. Earned value, so choice A is the correct choice. A manufacturing project has a schedule performance index of 0.89 and a cost performance index of 0.91. Generally, what is the best explanation for why this occurred? What's that? D? Yes, it's D. But what? We're thinking that probably B was better? Because we had to find a new one? I mean, in theory, it could be. That could be part of D, right? But yes, it's D. You are about to take over a project from another project manager. The worst. And find out the following information about the project. Activity Z has an early start of day 15 and a late start of day 20. Activity Z is a difficult activity. The cost performance index is 1.1. The schedule performance index is SPI is 0.8. There are 11 stakeholders on the project. Based on this information, which of the following would you be the most concerned about? A. Isn't that nice? All that mumbo jumbo in that whole question, and you define it easily and simply by 1.1 and 0.8, and you can tell we're worried about the schedule. Pay attention for those kinds of questions. This is why these are the easiest questions of them all, because earned value management is subtraction and division, and it's recognizing the numbers, and once you recognize those numbers, these questions are a piece of cake. Look at that, how easy that was. You blew away all that information and got right down to the answer, which was 0.8 or 1.1, and that tells you that 0.8 is the thing to worry about because you're behind schedule. Okay, here's another formula for the estimate at completion. This one looks pretty simple, doesn't it? Everybody understands this one? What this is telling us? What this is telling us is that we've done, or whomever we just took this project over from, has really messed up pretty badly with their planning. They haven't planned properly. So what they're telling us is, throw out all those numbers and start all over again. Here's our actual cost. Within week 2 of our project, we've got $5,500, and we've got 6 weeks left on our project. Let's just do a bottom-up estimating. Let's take those tasks that we have for those 8 weeks remaining and re-estimate them based on things like expert judgment, or maybe reviewing some other types of projects that we've done in the past, because maybe this project is in Thatcher, and maybe we can go to Watkins Glen, and we can build those, we can base those estimates on hiking trails that we built at Watkins Glen to build the hiking trails in Thatcher, right? That's our taking a look at an analogous estimating type thing, or we can take a look at maybe parametric, which might be the fact that we're analyzing the square footage of those trails, okay, to see how long it takes to build a square foot of a trail. So that's what this other estimate at completion is. Does everybody understand that formula? This one's a nice one because it's pretty easy, right? Yeah? Based on the information in the question, you should be able to tell what assumption they're expecting you to have, okay? So you're going to have to know those different formulas for estimate at completion and then figure out which one to use based on the information they've given you in the project or in the question. So it may be that they might say, the project sponsor said that the previous project manager didn't know how to estimate properly. So what are you going to do? You're going to use this formula, right? Okay, actual cost plus BAC minus EV. That one's kind of nice, isn't it? That's another easy one. Why? Because BAC minus EV, what's that telling us? Huh? Work remaining, exactly. It's telling us what our estimated earned value is going to be. In our example, it was, no, I don't remember what it was. It was 30,000, our budgeted completion was 30,000, minus our earned value, which was 6,000, which gave us 24,000, which is our new idea of planned value, or our estimated earned value that we're going to have for the rest of the project. Therefore, it would be the AC plus that amount. This one here we can kind of see is almost the same as the one previous to it, but then it has a bunch of numbers at the bottom of it. Our cumulative CPI and our cumulative SPI we didn't really discuss during this class. Basically, what those concepts are is it's doing a accumulation of the different time periods that you've run the different performance indexes. So what you're going to do in your report is you're going to run and you're going to find the values that you need for to calculate your performance index, and then those values at the end of all of the phases, if you've done period 1, 2, and 3, then at the end of period 3, you're going to calculate all of those numbers, the earned values added up and all the actual costs added up, and then determine your performance index for the whole project as opposed to the particular periods. Because generally, we're just looking at our performance indexes by the different periods. We'll look at a performance index for period 1, and we'll look at the performance index for period 2, and then a performance index for period 3. But then the cumulative performance index are the 3 periods all together, okay? And it's not as simple as just taking a average of your different performance indexes. You actually have to have the figures and sum them up and then run the numbers at that point. Now, this one basically is adding these 2 additional numbers at the bottom and creating a new index, a new ratio based on your performance index of your schedule and your cost in order to give you an estimate at completion based on what those numbers are. And I'm not going to run through any calculations with them because I'd actually have to think about it for a little bit before I could probably explain it properly. And I didn't actually look at it before. But from what they're saying in RETA, this is what we're using in order to ensure that we hit a firm completion date, is what they're saying. So this is by adding in some information to it and adding those performance index numbers in there so that it helps you recognize what you need in order to complete the project based on what some project sponsor has told you.